Okay, so let's buy some chickens. Rather than jump straight to 4 though, let's create 4 different flocks. The first flock will buy 1 bird and see what that distribution of possibilities would look like. Then we'll buy 2, then we'll buy 3, and then we'll buy 4. I think the reason I want to do that is twofold. First of all, more practice with distributions, making sure we understand how to put one together. But also, I want to kind of connect some dots between what your mind feels logically and mathematically backing it up. One of my favorite things to do with probability is measuring the idea of gut feelings, and I think this is a great way to do it. So, our flock number 1, we're going to buy 1 bird, and we're going to keep track of, since when we keep backyard chickens, generally we want the eggs, so we're going to keep track of the number of girls that we end up getting, or the number of hens. Probability. All right. So, when you buy 1 bird, or 1 pullet, I guess, you're either going to get no girls, or you're going to get 1 girl. So if Max goes in the store and grabs Nancy here, we named the first flock of 4 after our grandmothers. So here's Nancy, the Orpington. It's a wonderful backyard chicken, by the way. The Orpington breed, I guess. Super fuzzy, super great egg layers, and great personalities. So if we only buy 1 bird, you're either not going to get a girl, which means you get a rooster, or you're going to get a girl. Now that one right there, we already know because Joel told us what the probability was, 90%. 0.9. That must mean that there's a 10% chance that that chick is a boy. Because these add up to 100%. Just like we've known ever since we started talking about distributions, the sum of the probabilities has to be 100%. And I would tell you to average this distribution, but it's kind of silly. And we'll do a couple more on the board here, then we'll move to Excel. And it's much easier to do the averages in Excel. It saves you all the writing. But anyway, this is what the distribution would look like for a single pullet. What I'll do next is I'll clear the board and we'll buy 2 pullets. Okay, let's buy 2 pullets. Let's buy Nancy and let's buy Marge. These were my wife's grandmother's names. Nancy and Marge. So, Marge was what was known as an Americana. They lay the Easter eggs, kind of fun little green eggs. She was the most standoffish of the birds. I think that's an Americana trait, but they were nice. Very, very beautiful when they grew up to very, very nice chickens. Anyway, we're going to buy 2 pullets, Nancy and Marge. Hopefully you can see there's a possibility they're both boys. There's also a possibility they're both girls. Or there's a possibility that we get 1 of each. Now this is probably starting to remind you of your probability project, your second project, where we had to deal with this kind of thing. And I told you to kind of ignore the middle probabilities for now in the project. We're going to deal with them right now in this video. Now let's start with the end probabilities, which I think are a little bit easier. Let's look at the chance. Actually, let's go down here. What's the chance they're both girls? Well, if they're both girls, that means Nancy has to be a girl and Marge has to be a girl. And, as you remember, means to multiply. So that means first, Nancy has to be a girl, and then Marge has to be a girl. Which means there's an 81% chance they're both girls. Now, that should make sense intuitively. It's going to be harder to get both of them to be girls than it was just to get 1. And each additional chicken, as you'll notice, is going to get harder and harder and harder to get all female. Now, let's also look at what the chance of getting no girls is. Well, that means they both have to be boys. This is also going to be very hard. Exponentially harder than only getting 1 boy. Because if Nancy were actually a rooster, there's only a 10% chance of that happening. And then if Marge is also a rooster, there's a 10% chance of that happening. Which means there's only a 1% chance. There's definitely a chance, but it's a small chance that they're both boys. So there's an 81% chance that they're both girls, and there's a 1% chance that they're both boys. That tells us everything we need to know, because we still know this. We still know that the chances have to add to 100%. So we know 81 plus 1 is 82%. We know this has to be the other 18%. So we know the chance that one of them is going to be a girl is about 18%, which means roughly 1 out of every 5 times you buy 2 birds, you're going to get 1 of each. But the catch is, if we try to apply the multiplication property to this, we don't get 18%. Because, okay, let's just say we get a girl and then a boy. Well, a girl is 90% and a boy is 1%. 0.9 times 0.1 is 0.09. That's half of what it should be. And this is something I had you think about in that project you did, that joint probability project. And you came up with it then. The difference here is that we assumed the first bird was a girl and the second bird was a boy. In other words, we assumed Nancy was a girl and Marge was a boy. But couldn't it also be that Marge is the girl and Nancy's the boy? So saying it out loud using the language of probability, it could be that Nancy is a girl and Marge is a boy, or completely disjoint, Nancy's the boy and Marge is the girl. So it's 0.9 times 0.1 plus 0.1 times 0.9. And that's extraordinarily cumbersome to write that way. Hopefully you realize that mathematically this and this are the same thing. So what we end up just doing is putting a 2 in front of that, because that's the same as adding this to itself 2 times. We got so wrapped up in figuring out where that 2 came from that I forgot to get all happy, because now you see why the 0.9 times a 0.1, which only equaled 9%, has to equal 18%, because there are actually 2 9%. 9% of the time, Nancy's the girl and Marge is the boy, and the other 9% of the time, it's flipped, and there's your 18%. And that's something, like I said, we made peace with that in the project. Let's make peace with it some more and buy a third chick.